So quiz 2 compared to quiz 1, the average was a lot lower, which I expected after I heard some of your feedback. So we kind of talked about quiz 2 last time, but I don't want all of these, our quizzes to be as difficult as quiz 2. Sometimes it's hard to estimate or predict how hard or easy a quiz is going to be. So that's why at the end of the semester, I'm going to look at the average for the class, and if there should be a curve, or if there needs to be a curve, then I'll apply a curve. I haven't had to apply a curve ever yet, and I've been teaching after this semester, it'll be 2 years, but haven't had to apply a curve yet, but if I do for this semester, then of course I'm going to. But the majority of your grade comes from the projects that we're going to do later on. But of course, you want to do well in the quizzes, of course. So let me pull up the average for the quiz. I forget it off the top of my head. First, I'm going to look at quiz 1. So the average for quiz 1, let me go back. Alright, the average for quiz 1 was a 79%. So that's pretty good. And then let me check for quiz 2. For quiz 2, it was a 54%. So really big difference there. So if you were right around there, then you got the average. Again, it was at 54%. So, much lower than I like to have. But we talked about we'll have fewer questions in the future, so you have a lot of time to work on it for your 15 minutes that you have at the end of class. Alright, and I didn't write down the breakdown, but if you're curious, there was 5 people that got 100% actually, and then there was a few more that had A's, but of course, looking at the average, most of you were right around 50% because, there's a few questions. There was only 3, and for certain parts, like part B of question 1, which is when we had to do array addressing, if you didn't do that part, that was already 6 points lost. And then, of course, the last question, 2, if you didn't do that, or if you could only get to some of it, then that was a lot of points there, too. So your third quiz, that'll be this coming Monday, and that's going to be on element by element operations, and then matrix multiplication. So basically, you should study and do your homework that I just assigned on, when was that, Monday? So I'm going to pull this up too. But your third quiz is going to be basically based off the homework. The quiz is this coming Monday. And your homework is due then too, but just like last quiz, I'm going to post the homework solutions the day before the quiz. So I'll post the homework solutions on Sunday.
So, the quiz is based on the homework, basically?
Yeah, it's going to be very, very similar to the homework.
Okay.
Because for this stuff, a lot of it is kind of testing your understanding more than anything, because you could go into MATLAB and just try to do an element by element multiplication or something. But what I care about is that, you actually understand if you can do it, or if you can do matrix multiplication. So let me pull up the homework.
When will they be posted?
What was that?
When the homework solutions will be posted?
I'm going to post the solutions this Sunday.
Okay.
Yeah. Okay, so this is the homework, if you haven't looked at it yet. So again, it's probably going to look a little different than the typical homework. So we're going to start out with some short answer. That's not going to be on the quiz, but this is just for the homework. The quiz is going to look more like these questions down here. So the homework, there is quite a lot here. The quiz won't be this long, of course. But basically, you're going to be given some vectors or maybe some matrices. And from those, I'm going to ask you if we can do specific operations on them. So can we do A times B element by element? Can we do it element by element for B times A? And A times B for matrix multiplication. And also, if you can do the operation, what do you think the results, or what do you think the size of the result is going to be? So stuff like that. So I would really recommend when you do this homework that you actually look at these matrices and vectors first on your own before even going into MATLAB, and write down yourself what size, or well, first think about if you can do the operation, and if you can, what size you would expect for the output. That's really going to help with your understanding rather than just, plugging it into MATLAB and seeing whatever it spits out. Okay, so any questions on this homework or the upcoming quiz? Okay, and let's see, what else do we got? I want to make sure we talk about everything that I had planned. Okay, so yeah, now we're gonna finish up on what we were doing last time. So we're first gonna do a little review again, because I really want to emphasize, understanding element by element operations and then matrix multiplication. So we're gonna start out with review, and then we're gonna finish up chapter 2. That shouldn't take too long, and then we're gonna start plotting, which is, if you're following along the book, plotting is, I think, chapter 5. So we're kind of skipping a few chapters, and then we're going to go back to those chapters. Okay, so before we get started with the lecture, though, I want you guys to take a look at these, two vectors here that I made, A and B, and then this matrix C. And it's kind of like your homework and what your quiz is going to look like here. Think about first on your own if we can do the following. So, you can kind of write out a comment, yes or no, and if you can do that operation, write out the size that you think it's going to be. So I'm going to give you guys a few minutes here to work on this, because we have, a few questions here. I'll give you like 5 minutes or so to work on it, and then we'll go over it as a class.
Hello? Patrick, can you your mic is not on.
Yeah, it's on. We're doing exercises right now, so you need to.
Sorry, my bad. I just came in a bit late.
Okay, yeah, it's okay. So there's the question too. Isn't 1 and 2 the same? There's a transpose operation after b. So it's putting b to a column vector. Okay, so I'm going to give you guys a few more minutes. Hopefully you're working your way through here. Alright, so I'm going to give you one more minute, and then that'll be 5 minutes gone. Alright, how's everyone doing? You guys finish?
Yeah.
Okay. Alright, so we'll go over it as a class. Even if you didn't finish it, you can, I guess, follow along here. Alright, so first one that we have to do is element by element multiplication of a times b. So we have two row vectors basically. So first we can just, type this in. I'll actually just go in the command window here. So I'll do a times b. I need to run my script first. Okay, there we go. A times b. And press enter. And you'll see that it says matrix dimensions must agree. So before we saw that we could do multiplication with like a element by element multiplication with a row vector and a column vector. But in this case we have two different row vectors and they're different sizes, and we can't do it in this case because when we have two vectors that have the same dimensions, so either a row vector or both of them are row vectors or both are column vectors, they have to have the same length. Because we have we're trying to do basically 0 times 4 for one index, and then 3 times 4 for the second, 2 times 4 for the third, and then we don't have a fourth index in A to match with the fourth index in B. So because of that, we can't do this element by element multiplication. So it's a little different when we have vectors have different dimensions. So if B is instead a column vector, then we can do it, which, you see in the second part here. So I'll first say no. Vectors are vector same dimension, need to be same length. Okay, so the second one, we have element by element multiplication of that row vector A with basically what's now a column vector for B because we transposed it. So in this case, yes, we can say that these sizes are compatible. So remember, we kind of use that terminology for element by element multiplication. So if I do A times B transpose, and then I run this, then we get an output, in this case, that's 4 by 3. So we have 4 columns, which corresponds to the 4 rows, which corresponds to the 4 rows that we had in B transpose. And then we have 3 columns, which corresponds to the 3 columns that we have in this row vector A. So, yeah, I want to make sure you all get this. So does it make sense so far? Okay, so there's a question about the inner numbers. That's not what we're actually looking at quite yet. So when we look at the inner numbers, we actually look at those when we do matrix multiplication, not element by element multiplication. Okay, so can I explain it one more time? Yeah, so I'm actually going to go back to the beginning and go over the first one more time too. Okay, so this first one we have two row vectors, A and B, and we're trying to do element by element multiplication. So when we're doing an element by element operation, MATLAB wants us to have one index working on another index. So we have this first index in A, MATLAB wants to multiply that by the first index in B. So it can do that, so it's good so far. Then we'll go to the second index in A and multiply by the second index in B. We're good. Then we're going to go to the third index in A, multiply that by the third index in B. Still good. Now MATLAB is going to look for the fourth index in A to multiply with the fourth index in B. But in this case, there's no fourth index in A, so MATLAB can't do this operation. So we could, well, I won't say that quite yet, but if we try to do A times B, element by element multiplication, then we can't do that because, again, as it currently stands, there's no fourth index in A. There's nothing there. And now if we do A times B transpose, so that's basically a row vector multiplied by a column vector. Even more specifically, we have a 1 by 3 row vector multiplied by a 4 by 1 column vector. Let me make that comment too. So we have a 1 by 3, that's our row vector. And we're multiplying this by a 4 by 1 column vector. So, my camera just died. Oops. That's okay. Okay, so there was a question if we're looking at the inner numbers. So we're not looking at the inner numbers quite yet. We look at those once we do matrix multiplication. But for element by element multiplication, it doesn't matter. Okay, before I continue on, there's a question. So basically, any multiplication that is transposed is always going to be allowed, if that makes sense. For this exercise, yes, because we're multiplying a row vector with a column vector. But you need to pay attention to the dimensions that you have. So basically, if you have vectors that are the same dimension, so if they're both column vectors or they're both row vectors, they have to be the same length. But if you have a row vector multiplied by a column vector, and you're doing it element by element, then the length for each one doesn't matter, which we're about to see here. So for the second exercise, we have a row vector 1 by 3, and a column vector that's 4 by 1. So you see that those dimensions are different. We have a row vector and then a column vector. And because of that, then we can do that multiplication, kind of like we saw in a past slide. Let's actually go to it. So in this slide here, right, we had a 1 by 3 row vector and a 3 by 1 column vector. Here's actually what we're doing right now, a 4 by 1 column vector here. And we can do it element by element because we're doing 0 times 1, and then 2 times 1, and then 4 times 1. So that works. And then we go down to the next row, 0 times 2, 2 times 2, 4 times 2. And we keep kind of going in that pattern. And that's exactly what we have in this exercise here for A times B transpose. Okay, so does that make a little more sense? I know it's kind of like a lot of bookkeeping to kind of keep in your head, but once you do more and more exercises, especially with the homework, it should kind of clear things up. Okay, if there's no questions, then I'll go on to the next one. Okay. All right, so the next one we want to do is element by element multiplication of A times C. So I'm going to put out the sizes again, just so we can kind of get a better idea of what we're looking at. So A, again, that's a row vector. That's a 1 by 3 row vector. And C, I really should have made this a capital C because it's a matrix by convention. And that's a 2 by 2 matrix. So for this, we're trying to do essentially matrix multiplication. Let me rephrase that. We're trying to do element by element multiplication between two matrices. So if you remember this from a past slide, when we're doing element by element multiplication with matrices, the matrix dimensions have to be identical. I should have a little summary here. Summary. Where is it? Here. Okay. So when we're trying to do element by element operations on matrices, the dimensions have to be the same. And that's what we're kind of looking at in this exercise here. We have a 1 by 3 matrix, which is just a row vector. And then we have a 2 by 2 matrix. So those sizes are different. They're not identical. So because of that, we can't do this element by element multiplication. So if I do A times C, I need to run my script to update to a capital C. So A times C, and it's going to tell me that the matrix dimensions must agree. So does that part make sense too? Okay. All right, so now we're on matrix multiplication, and now we're going to start to look at the inner numbers and the outer numbers. So remember, looking at the inner numbers, that's going to tell us if we can do matrix multiplication. And then if we can do it, then we look at the outer numbers that we have, and that'll tell us the size that we're going to get for the output. Okay, so let's do, we have first A times B, so we have a 1 by 3. We have a 1 by 3 row vector, and then we have a 1 by 4 row vector as well. So if we look at these inner numbers, we have a 3 and then a 1. Those are different, so we can't do that matrix multiplication. So I'll do A times B, and it tells us, nope, you can't do it. And then it even tells us, okay, maybe you meant to do element-wise multiplication. Even if we tried that, we saw from earlier on that that also doesn't work because we have two row vectors. Because we have those two row vectors, they have to be the same size. Okay, there's a question. So matrix multiplication is when we don't have the dot. So yeah, that's correct. Matrix multiplication is just the multiplication sign, the star. Okay, so inner numbers don't match. Can't do it. Okay, oops, I'm looking at the wrong part here. Let me cut that and put it here. Alright, and again, that's because we have a 3 and a 1. So we can't do it. The next one we have is matrix multiplication of A times B transpose. So that's going to be 1 by 3, and then we have 4 by 1. Those inner numbers, they still don't match, so we can't do it. So if I do A times B transpose, it's going to give us an error once again. And then the last one we have here, we have a 1 by 3, that's our row vector A, and then we're multiplying by our matrix C, that's a 2 by 2. So again, they don't match up, so we aren't going to be able to do it. I'll do A times C, and it doesn't work. So just for our own sake, let's actually do one that will work. So let's go back up here. I'll make a new matrix called D, and let's make a matrix with 3 rows here. So we'll do 0, 1, 2, 2, 3, 3. Okay, so matrix multiplication of A times D, this will be a 1 by 3, that's our row vector A, And then our matrix D, that's a 3 by 2. So we have 3 rows and 2 columns here. So now the inner numbers, they do match. They're both 3. So that means that we can do this operation. And we're going to look at the outer numbers now, and that's 1 by 2. So the output that we should have now is 1 row and 2 columns. And that's what we get. Okay, there's a question. If we transposed A instead of B, it could work, right? So you're, do you mean this? Doing matrix multiplication of A transpose times B. So if we do that, then we're going to have a 3 by 1. And then we would have a 1 by 4 for B. So yeah, in this case, it would work because those inner numbers, they match up. So let's do that too. We have A transpose times B, and then we get our output there. And then I should have also mentioned, we look at the outer numbers, and that's a 3 by 4. So we have 3 rows and 4 columns here. Okay, so everyone clear on this? Maybe, you might want to look back at this lecture once it's posted, or kind of go through these examples again on your own to really make sure that you understand when we can do an operation. And if you can do it, what the size is going to be. All right. Are there any questions before we go on to some new stuff? Yeah, my D matrix is just this 3 by 2. Okay, so if there's no more questions, then we're gonna move on.
Patrick,
Mm-hmm.
if C was a 3 by 3 matrix, would A times C work?
If C was 3 by 3?
Yeah.
Yeah, it would work then. So in that case, it's kind of similar to what we have on this example here. So those inner numbers, they would both be 3. And then the outer numbers would be 1 by 3, so that means the output would be 1 row and 3 columns.
What about for the element by element?
For that, if we had 1 by 3 and then 3 by 3, it wouldn't work because those dimensions are different. So I'll do this right now. Actually, let me show you. I'm gonna change D to be 3 by 3. Okay. So we want to do element by element multiplication of A times D. So that's a 1 by 3 row vector. And we have a 3 by 3 matrix. So, I say this is a 1 by 3 row vector, which is correct, but that's even more specifically, that's a type of matrix. So this is a 1 by 3 matrix, and we have a 3 by 3 matrix. And if we're doing element by element multiplication between matrices, they have to be identical in size. So if I do A times D, element by element, okay, I guess I look like a moron right now. It's because of these inner sizes here. Yeah, in this case it can work. So I guess I misspoke. Let's think about this. In this case, yeah, it's going to work because we have a 1 by 3 row vector, and then we have a 3 by 3 matrix. So in this case, we're kind of doing it. Let me type out A here again so we can kind of imagine what we're doing. So we're doing 0 times 0, that's going to work. And then we have 3 times 1, that's going to work. And then we have 2 times 0, that will also work. Let me pull this up. Okay, so we're doing, here, 0 times 0 is 0, and we have 3 times 1 is 3, and then we have 2 times 0 is 0. So we're kind of doing that first row, and then we can go into the second row by doing 0 times 2 is 0, 3 times 2 is 6, 2 times 1 is 2, 0 times 3 is 0, and then so on. Okay, so that was a very good question. That's a little oversight by me, so good job pointing that out. So there's another question. I thought it had to be 3 by 3 times 3 by 3. Yeah, oversight by my part. So in this case, it doesn't have to be exact. In this case, it was still compatible for the sizes because we have a 1 by 3 row vector and a 3 by 3 matrix. And then as you just saw, we're kind of doing it row by row in this case. We have this row vector, and then we're going to multiply it row by row for this matrix. And that'll give us our output.
So, do you think that could also apply to column matrices or column vectors?
If you have a row vector multiplied by a column vector?
No, a matrix versus a column vector. Instead of a
Yeah.
row vector.
Yeah, that should also work as well. Let's make sure though. I don't want to misspeak again. So I'll do A transpose times D. And yeah, same thing, it does work in this case. And so yeah, that's just like the row vector, but instead of kind of multiplying this row vector by this matrix row by row, we'd be multiplying the column vector by the matrix kind of column by column. Okay, so any other questions before we move on? Okay.
Oh, sorry. I have a question.
Okay.
Can you explain what goes on by when you do the matrix multiplication of A and D?
Yeah, this one right here?
Yeah.
That's highlighted? Okay, yeah, sure. Okay, so we have matrix multiplication of A times D. So A is a row vector that's 1 by 3. And then D is a 3 by 2 matrix. Actually, now it's a 3 by 3 now. I changed it. Okay. So we look at the inner numbers to see if we can do the matrix multiplication. So we look at this number here, and then this number here. And if they're both the same number, then that means that we can do the matrix multiplication. So in this case, they're both 3, so that means that I can do it. So after that, we would then look at the outer numbers to basically know the size that we're going to get for the output. So in this case, that's 1, and then a 3. So that's a 1 by 3, or 1 row and 3 columns. So if I do A times D for the matrix multiplication, then we get an output of 1 by 3. So we have 1 row and 3 columns here. Does that make a bit more sense?
Yeah, but D has like three arguments in it, right? Oh, 9. Never mind.
It has 9 indices, yeah. That doesn't, necessarily matter for us in this case. We just want to look at these sizes here. So the first thing is looking at the inner numbers, 3 and 3. So since they're the same, we can do that matrix multiplication. And then we want to look at the outer numbers, and that'll give us what the output result is going to be, which is a 1 by 3, which is what we saw here. So matrix multiplication is different than element by element multiplication. I think I showed you the actual math in one of my slides. Yeah, here. So I showed you the output, or this is element by element multiplication. I think in one of my slides I showed you the kind of math for matrix multiplication. So you might want to look at that again, or if you have questions too, I can kind of show you. I can write it out sometime.
Okay, yeah, for sure. Thank you.
All right, so again, I know there's like a lot of kind of, bookkeeping or understanding to kind of keep in your head. So just make sure that you go through, I would recommend going through these exercises again on your own, and then also going through the homework. Really go through the homework slow and make sure that you understand it all.
Are we gonna get an email sent with like the topics that are gonna be on the quiz?
Not this time, just because it's going to be basically what the homework is like.
Okay.
Yeah. Okay, so let's start out. I'm not going to go over all of the slides here that I have at the end, only because some of these I actually go into far more depth once we start doing the plotting chapter. And some of these we've actually kind of already gone over before. So we've already talked about polynomials and how we define them in MATLAB. Let me make a new section. No quiz today, quiz on Monday. Okay, so we went over how to define a polynomial in MATLAB before, which is really just a row vector, right? So if we wanted to define this polynomial here, 2x to the third plus 3x squared plus 7x plus 8, in MATLAB all we would do is make it this row vector. And it could still be interpreted as a polynomial depending on what we do with that later on. So if we create a polynomial, we can find the roots, which we found or which we went over before. So to do that, all we do is define the polynomial, and then we use the roots function to find the roots of that polynomial. And we can be more concise here if we want, but in this case, we could do it on one line, so I can have roots of whatever my polynomial is. And that's okay, but this is also assuming that we don't need to store this polynomial here that we have defined as a variable. So, maybe later on in the code I'd want to reference this polynomial again. And how we currently have our code is we'd actually have to type it all out again, which, isn't really ideal. So often we define things and assign them to a variable. So if we know the roots of a polynomial, we can actually find the coefficients from those roots. So basically we're kind of working in reverse now. So we know the roots of some polynomial, which we have here. These are the roots here. And we can use the poly function, which will then give us the coefficients for that polynomial. So you see here we have 1, -9, 33, and -25. And that would correspond to the polynomial of x to the third minus 9x squared plus 33x minus 25. Okay, and then if we have two different polynomials here and we want to do an operation on them, like in this case adding them to create a whole new polynomial, how could we add them? So this is basically element by element multiplication, right? And if we tried to do this right now, it wouldn't work. It would say that the matrix dimensions must agree. So basically we have to trick MATLAB into thinking that the dimensions are the same. So we just need to put in a 0. In this case, we're going to put in the 0 in the beginning of our polynomial for g, because remember, we have 5x plus 8. So really we have 0x squared plus 5x plus 8. So that's why we would put a 0 in front. Okay, so we do it like this, and then if we try to add them, f plus g, then we could actually add them to get this new polynomial that's, in this case, 2x squared plus 8x plus 17. Okay, scalar multiplication, we went over this before. And then we can do polynomial multiplication if you want. That's using the convolution function. I won't go over this stuff too much just because I want to get to plotting. And to be quite honest, we don't use this too often unless you're doing it for like a math class or something. And something to note though, the polynomials do not have to be the same length. Then there's polynomial division, which is really synthetic division, if you remember that from math class. Kind of nasty stuff, I hate it. But we can do this in MATLAB, and you don't have to do it by hand. And then we have evaluating polynomials, and this is where I'm going to kind of stop because we're going to be going over this in a lot more detail in the plotting chapter. But you can imagine that we have a polynomial, in this case 5x plus 2, and we could have some range of values. So these values, you can kind of think of it like the x-axis on a plot. And then we could evaluate the polynomial that we have. In this case, it's called poly. And we could evaluate it with all of these, this kind of x range here, to get the corresponding y values for our polynomial. And once we do that, we can then make a plot with that, which you'll see looks like this. But again, we're going to be going over this in a lot more detail once we start our plotting chapter, which we're going to do right now. But once we get to plotting polynomials, that's a bit later in the chapter. Okay, so that's arrays. That was you know, I think our longest chapter. There's a ton of slides here. But arrays, you know, they're really, really important in MATLAB. We're using them all the time, right? We always define an array, or we're always working with arrays, as you'll see in our workspace. It's always some kind of array. I mean, it could be something like datetime, but we're always using arrays. That's my point. Okay, I'm gonna open up the slides for plotting now. And these were uploaded last night as well if you want to look at them. Alright, so we're going to be doing some pretty basic stuff today for plotting. Just the very basics of it. Let me make a big old section. Plotting. Okay, so we're going to be learning how to make 2D plots. I guess I put down 3D plots. I don't plan on going over those unless we have time. So maybe we will, but so far I only have slides for 2D plots. And we're going to be going over how to make multiple curves, label our axes, put in titles, put in data markers. We'll talk about formatting too for like your axis labels that you have. I mean, a whole lot of stuff. There's so much for plotting. It's a pretty big chapter too. Okay, so first off, we're going to be going over XY plotting functions. So to make a plot, we're going to basically make a plot from either data or an equation. So occasionally, from this point onward, we're not going to do it today, but at some points throughout the class, I'm going to give you data on Canvas, and you're going to download it, and then you'll import it into MATLAB. And we're actually going to work with that data to either to do things like make a script with it or to plot it. So we're going to do that occasionally. And I think once we have data, it's, at least to me, it gives more context to what you're doing when you make a plot versus plotting some like arbitrary math equation. Alright, so to make a plot, a 2D plot, we need to specify the x range that we have and the y range. So you can think of the x range something like a time axis, and then the y range is going to be the dependent variable that we have where we're going to plot something. So, it might be like position over time. So that'll be, one really, really basic example. And to actually make our plots in MATLAB, we use the plot function. So it's very, very intuitive here. We say plot, and then we give our x data, and then we give our y data. And then we can make our plot. And from this, we're going to add on a whole lot of other stuff to kind of clean up the plot and make it look nice. Okay, so what we're going to be going over is how to give an axis label, so the x-axis and the y-axis. We'll talk about how to specify tick marks that we have. We can adjust the kind of intervals that we have for these tick marks. And we can adjust the formatting for how many digits we have. I mean, you can do quite a lot here. And we'll talk about how to get a legend on your plot. We'll talk about having a smooth line versus a dashed line. And then we'll talk about data markers as well. We'll talk about colors. We'll talk about plot titles. Again, so much. We went over a little bit of this before, but we're really going to take a deep dive now. So, to make our plot, we're going to assume right now that we have some x vector and some y vector. So the x values, they're going to go on the x-axis, and the y values are going to go on the y-axis. And by default, MATLAB is going to auto-scale your figure. So we can adjust this later on. We'll go over that later on in this chapter, but you can actually specify the size and the scale that you want for your plot. So let's do a really basic plot right now as a class. So make sure you're following along here too. So I'll make a section here. Let's do our first basic plot. So the first thing we're going to do is define our x range. Define x range. So again, you can think of this kind of like a time axis or something like that. So we'll do x equals linspace. We're going to use our old friend linspace. And we're going to go from 0 to 10. So our first value is going to be 0, and the last value is going to be 10. And by default, if we only give 2 arguments for the linspace function, we're going to have 100 elements in there. And you can see that in the workspace over here. Okay, now we're going to define our dependent variable, so in this case the y variable. And we're going to do y equals 5 times x, and then we're going to do squared. So this is when element by element operations, it starts to really come into practice here. So if I do 5 times x squared, just like this, we're going to get an error. Because what do we have? We're basically doing, we're multiplying 2 row vectors with each other. So right now it's trying to basically do x times x. It's trying to do matrix multiplication here for 2 row vectors, which we just learned from the previous chapter that we can't do. But we have 2 vectors. We have the same vector x, so it's going to be, the same length. We have to do that element by element for that multiplication. So I'm going to put in a little dot before the square operation. And then if I run it, then this actually works. So now again, basically what we were first trying to do, x times x, which is matrix multiplication for 2 row vectors, which we know can't work. So what we instead have to do is x times x, doing element by element multiplication, and that does work for us. So let me put in that dot there again. Okay, there's a question. When I start a new script, it's opening an entire new page. How can I go back to the original format? I don't know if you mean the first script that you have, but you should be able to open up multiple scripts at once. Stick around after class and show me, and then I can kind of debug it with you. Okay, so we have our x variable and our y variable, okay? And before we move on, I want to make sure all of you understand why we did element by element, basically multiplication here for x squared. Okay, I'm going to assume that's a yes. If you don't get it, make sure you tell me though. Okay. Alright, so now we're going to make our plot. So to make our plot, all we have to do is use our plot function that we talked about. So plot x comma y. So let me go back here. So we get our little pop-up, and MATLAB tells us, basically the main function that we're going to be using is plot, and then, the most basic form of this function is giving 2 arguments. So giving the argument for the x values, and then giving the argument for all of the y values. So I'll do plot x comma y, and then I'll run this now. And then we get our plot here. This warning, you might have saw it before. This is just for my system specifically, it's just a graphic thing. So don't worry about that. Alright, so if you ran your code, you should get a plot that looks like this. Alright, so that's a very basic plot, and what we'll do to this now is add in some labels and a title. And a legend. Okay, so I'll stick that right there. Okay, so to make a label, an x label, we type in x label, and then we need to have parentheses. And within those parentheses, we're going to have 2 apostrophes. And within those apostrophes, that's when we actually specify what the label is going to be. So for this, I'll do my x label. Just, I don't know, because. Okay, so one of you, your plot isn't showing up. It might, basically, if you go down to the bottom where your taskbar is, if you're using Windows, kind of hover over that, and that window might kind of be hidden away for your plot. Because if you're running a script, it should show up. Okay, then we'll do Y label. So to make a Y label is, the same as making an X label. We just put Y label instead. And for this, I'll just say my Y label. Alright, and then we'll add in a title. So to do that, again, it's very intuitive. We're just going to say title, and then we'll put whatever my title is. My fancy boring title. And then we'll run this right now. So I'm going to run it, and then you see on my plot, we get our X label that shows up, we get our Y label, and we get our title. Alright, and now let's add in a legend. So I don't really need a legend in this case because I only have one curve, but I'll show you how to make a legend because we're going to be using legends a lot later on once we start getting multiple curves on one plot. So to add in a legend, all you do is type in legend, and then you basically give the label for whatever curve that you have for your plot. So in this case, we plotted 5x squared. So I'll put in 5x squared. And now if we run this, you see that I get a legend that pops up. 5x squared. And I can also move this around wherever I want. You saw by default, it's actually not very ideal. It's blocking this plot a bit. For this plot, it's pretty basic. We're not missing too much information, but you want to try to make sure that you avoid having your legend block curves. So again, you can move it around wherever you want, or you can even specify in code where you want to have your legend positioned. We'll go over that later on as well. Okay, so any questions so far? Pretty basic stuff, but important too. Okay. Alright, so let's move on. So in this case, what we're going to do now is make a plot that has two curves. So we're going to work on making this plot here. So, often, you might just make a plot with one curve, but a lot of the times we're actually, we want to make a plot with multiple curves on there. So now I'll make a section, two curves, one plot. Okay, there's a question. I think I may have used the plot off command once and it doesn't show anymore. So stick around at the end of class and I'll help you debug that. I want to make sure that you can see your stuff. Okay, so again, we're going to be working on making this plot. So often we want to make a plot that has two curves on it. So we'll start out by making our x range. And we'll use the linspace command once again. So I'll do linspace from 0 to 100, and we're going to have a default length of 100 values. Okay, you see I just ran my plot, or my script, and my first plot keeps showing up. That can be kind of annoying if we're working on other stuff down here. So in the meantime, I'm actually going to show you guys a command to kind of prevent this from showing up. I think we went over it once in chapter 1. So I'm going to do figure. Before my plot function here, I'm going to go on the line before and I'll type in figure, and then in quotes I'll put visible, and then in other quotes I'll put off. And now if I run this, I keep running my code. You can see it in the command window, and my plot isn't going to show up. Okay. Okay, so we have our x range, and now we're going to define two different, basically dependent variables that we have. So one of them I'll call y1. I'll do y_1, and I'll do 5 times cosine of x. And the other one I'll do y2 equals 5 times sine of x. Alright, so there we go. Now let's plot it. So I'm going to do figure, visible, and then on. This time I want to see what the plot looks like. Okay, so we're going to plot our first curve here. So I'm going to do plot x comma y1. And if I do this right now, let's run it. And then here's what shows up. It looks pretty shit, to be honest, so far. We're going to go ahead and we're going to actually fix this so it looks a lot better. Also, yeah, I should have made this range from 0 to 10. Let's do that. Okay, so here's what it looks like now. It looks okay now, but we'll even make it look a little bit better. Okay, so here's what our plot looks like, but again, we want to have two curves on here. So what I'll do now is I'll use the hold on function. So the hold on function tells MATLAB that we want to plot another curve on that same graph. So right now we only have one curve. I want to plot another curve. So I'm going to tell MATLAB hold on, and then we'll do plot x comma y2. Alright, and then once we're done with all of the curves that we want to plot, we're going to say hold off. Now, I actually could run this right now, and you'll see that I get my new plot that shows up here, and it worked fine. But by convention and standard practice, you should make sure that you actually type in hold off once you're done plotting all of your curves. Okay, so if I run this again, then here we go. We have our plot with our two curves. And now let's add in some x labels and some y labels. Actually, before we do that, you see that our curves, at least to me, they look really thin, and I kind of hate how it looks, so I often adjust the line width that we have on the curves. You don't have to, it's just something that I always do because it bothers me. So to do that, we use the line width argument. Make sure that your capitalization here is the same as mine, so you need a capital L and you need a capital W. And then I'm going to do, in this case, I'll do like 1.5. By default, it's 1. Then I'll go down here to line width of 1.5. And now if I run this, we get our plot that looks thicker. On your screen, it might look a bit smoother than mine. Remember, I had a graphics warning. That's just for my system, but your plot should look pretty good now. Alright, so there's a question, how did I change the range? All I did was change this argument here for linspace. It was, at first it was 100, I just changed it to 10. So remember, linspace is gonna, in this case, it's gonna go from 0 to 10, and it's gonna have a length of 100, or there's gonna be 100 elements in that vector. Okay, so let's add in some x labels and some y labels now. Okay. So what we have here, I want to basically put in, these labels. So we kind of went over briefly how to make x labels and y labels. But now we're also going to add in some units here, or some fractions. I'm looking at this now. I actually have something different than what I have in my code. See, my code only shows inch, but if any of you took 331 stress mechanics, you know a strain is inch per inch, or it might be millimeters per millimeters, depending on your units. Besides the point. Alright, let's add in our x label, and I'll call this strain. And then I'm going to do inch divided by inch. Alright, and then let's run this again. Alright, and then here's what my x label looks like right now. And then I'll do y label, and we're going to call this stress. Obviously, if you guys took stress mechanics, you know this is not a stress strain plot. Nowhere close to it. Okay, so we have stress, and then we're going to do pound force per inch squared. And let's close this out. And then if I run it again, then here's our plot. And you see when I did inch squared, it actually puts the exponent up top for us. So it doesn't show this little caret it actually puts the 2 up top. So that looks nice. And then we'll add in a legend now, because remember we have 2 curves here, so in this case it actually would be very useful to put in a legend so we know which curve corresponds to what. So I'll put legend, and then my first argument is going to correspond to the first curve that I plotted. So in this case that was x and then y1. Y1 is the more important thing that we want to look at, because that's the dependent variable. So in our legend, I'm going to put y_1. And then for the second argument, that's going to be the second plot that we made. So I'll put y2. Alright, so I'll close this out and then I'll run this again. And now you see that I have this legend. Also, you see it actually puts 1 and 2 as a subscript. I think by default, it's kind of using Latex formatting in some instances. If you guys don't know what Latex is, it's just it's a typesetting program. So like kind of think of like an alternative to Microsoft Word. And if you put in an underscore in Latex, it makes it a subscript in math mode. But kind of a tangent. But that's just why we see subscripts here. Alright, so you will also see that in my figure, my labels look different than what I have in our current figure that we worked on in MATLAB. So, you see here that we have inch per inch, and then up here we have pound force per inch squared, and it's formatted differently than what I have right now in the class. So we can do this, and we're actually going to explicitly use Latex formatting. Now, this is mostly just for you guys. If you want your labels to look a bit better, I'm not going to require you to do this in a quiz or anything like that. So to do this, we're going to be adding basically some more, I guess, arguments to our X label and our Y label here. So first thing I want to do is put in parentheses and also make inch per inch. I want to make that like a fraction. So I want inch in the numerator and inch in the denominator. So what I'll do is I'll go to X label and I'm going to put 2 $ here. And these $, they stand for math mode in LaTeX. Yes, how do we get smoother graph curves? We'll go over that in just a sec. I'll do that right after I talk about this formatting. Okay, so we have those $, and I'm going to go over this quickly because it's not like something you'll be tested on. So first I'm going to do \left, which in LaTeX is going to give us a left parentheses, \left, and then we put the parentheses. And then I want to have, actually I need to move this over here. So I'll have strain, and then in math mode we're going to put inch per inch. Okay, so to do this, let me actually delete this. We want a fraction, so in LaTeX that's \fraction. And then we have 2 sets of curly braces. The first one is going to be the numerator. The second is the denominator. And then I want to close this out with a right parentheses. So we do that. And then I need to tell MATLAB to interpret that code there as LaTeX code. Interpreter. There we go. And then LaTeX. Now if I run this, then there we go. You see that it's formatted differently now. Alright, so anyways, that's how you can make it look a bit better. But yeah, up to you. I'm not going to test you on it. One more thing, our legend right now, it's boxed. Sometimes you want to remove that box, so you go on a new line and you type in legend and then box off. Now if we run this again, you see that there's no box around the legend. Okay, so question on how to make our graphs smoother, or the curves smoother. We just change the step size, that's it. So, remember, for length space, if we only give 2 arguments, that's the first point, or the first value, and then the last value. To specify the length, which will affect the step size, we add in a third argument. So by default, it's 100. Let's change it to something like 10. This is going to look really bad right now, but let's run this. And you see how terrible this looks now. That's because we only have 10 elements in each of these vectors that we were plotting here. So there's only 10 points. So if I, yes, use more. So if I make this 1000, then now it's going to be very smooth. Okay, and to actually show this even more, and to know I'm not going to use even more, because there's going to be very negligible differences. So if I put this as 10, and I'm going to change the plotting format here to show you all of the points that we have. So I'll do comma, and then let's do, that should just work like this right now. Yeah, see, you can see the points that we have here. And let's actually change this to circles and then a line. And then you can see that we have a line and then all those 10 points that we have. So it looks, you know, really, really bad with only 10 values. Over 9,000. Yeah, so usually I just keep it at 1,000. Depending on your data, it may or may not be enough. It most likely will, though. Okay, so anyways, that's how you make it smoother. Just increase the number of elements in your x vector. All right, any questions so far in plotting? All right, if not, I want to give you guys this exercise. We'll kind of finish off here. So work on plotting this, okay? So we're going to have an x domain from 0 to 4, and you're going to have 1,000 elements. So hint, use the linspace command. And on this, oops, don't look at that. On this, we're going to be plotting two different curves. So we have y, that's one curve, and z, that's going to be another curve. And then also make an x label, a y label, a title, and a legend without a box. And if you really are adventurous, you can use Latex formatting for the legend, kind of like you saw in this line here. Alright, so I'm going to give you a few minutes to work on that. I made this exercise kind of a pain in the ass for defining y. Alright, I'm gonna give you maybe another minute or two. Yeah, so if you want to move the legend around to like the bottom corner, you can just click and drag on it. Or you can actually specify the location with code, and I'll show you that actually. Okay, so I'm gonna go over this now with you, so hopefully you made some progress on here or finished it. So the first thing we're going to be doing, let's make a new section. Alright, first thing we want to do is define our x range. So we have x equals linspace. We want it to go from 0 to 4. and we wanted 1000 elements in here, so I'll do 1000. Next, let's define y and z. So I know y was a pain in the ass. That was intentional. This is actually from last semester. I forgot I made it that kind of complicated. So we have 8 times e, and then we have, within this, remember when we have e, we need to put our argument in parentheses here. So we have minus 2 times x, and we have x squared again. So remember, x in this case, that's a vector. So because it's a vector and we're doing x squared, or really x times x, we have to do element by element operations. So make sure that you put in that period before the exponent, or before the caret. Right, and then we have times 4 times sine of x. And so remember, trig functions, they are vectorized functions. So because of that, we need to do we need to have this element by element multiplication here. So we're going to do sine of 3 times x. Alright, so there's y. If we run this right now, then we're good. Let me go up here and put this as off. Okay. And then we're going to define z. So we have z equals 10 times x, and then we have squared, so we have to use our element by element operation once again. That's 0.2 times x. Oops, no, not times x. Okay, there we go. Alright. Just making sure I typed it in right. Oh, negative. Okay, there we go. Alright, and then now we want to plot this. Okay, so we do plot x comma y. That's going to be our first plot. Let me actually make a comment. Alright, and then we want to plot z as well. So we're going to do hold on, and then plot x comma z. There's our second curve. Now we're done plotting all the curves, so we'll do hold off. I want to have an x label, so we do x label. Let's pretend that this is time. And I can actually just go on the same line, and I can put in a y label. Then I can have title, my title. Usually I like putting x label and y label on their own line, just because it's more clear to me, but it doesn't matter. And then we can put in our legend as well, but I'm really running out of time here, so I'm just going to call this y, and this will be z. We'll go over kind of some of the formatting again next time, because the formatting does matter. For, you see I have like curly braces here. That's important. So I'll go over that next time, but we're running out of time. And I also need to do figure visible on. Right, and then here are our 2 plots. So there we go. And then again, we can move around our legend here. If we want to specify where the legend is positioned, I always forget if it's a location or position, so let's first see. And then I'll do south, east. I think this is all lowercase too. Spell it correctly. Yep, there we go. So if you want to specify the location of the legend in your code, you have to use these arguments here, and the capitalization does matter. Okay, so we're out of time now, so that's a brief on plotting. We're going to be doing more and more advanced stuff here, but that's a good intro. So that's it for today. Your homework is due on Monday. Your third quiz is on Monday at the end of class, 15 minutes. It'll be less questions than last time, so you have more time to work on each question. And your homework, I already said that is due on Monday. I'll post the solutions for the homework on Sunday. Alright, so that's all I have for you guys today, so you're free to go. If you have any questions, then stick around. Alright, have a good weekend.